Representing vectors. We can think of vectors numerically, and we can think of them diagrammatically. Here, A has been drawn for you. It's 3 across and 2 down. Remember, X is at the top, then Y is at the bottom. We could perform operations such as addition numerically and multiplication. We could do this numerically. However, we could also sort of do this diagrammatically. For example, if this here is A, B is 0 minus 1, B could be drawn on as well. And the resulting being a key word such as resultant, the resultant vector of A plus B. Can you see that that's also 1, 2, 3, 1, 2, 3 down? That also gives us this answer here. 2A, if I wanted to represent that, I would just draw another A stacked on the end. A unit vector. So a unit vector is a vector of magnitude 1. Unit vectors, we often discuss sort of I and J, okay, especially in mechanics. And I is going to refer to a horizontal movement. So this would be 1I, and this here would be minus 1I, or we could write this as minus I. And we do up and down for J. What does this mean? It doesn't really affect very much, to be honest. It's just another way that vectors might be written. So you'll often see people write something like this. 4I plus 5J. That really, though, is exactly the same as doing this. Okay, so you don't need to worry too much about the detail of this. A is 3I, so 1, 2, 3 to the right, that means. B is I plus J. If there are no numbers, it means that there's a 1. So B is like this. C is I minus 2J. Okay, so in vector form, we could write it like this. For the second part, B plus 2C. Well, I mean, I would say most of the time I would sort of treat this as this, 1 minus 2. What does it say? It says 2C. So if you do this, what you do is you multiply top, multiply bottom. Okay. And then I would add B. I would add B to it. So this is plus 1, 1. Can you see that you would get 3 minus 3, which can also be written as 3I minus 3J. It does say here, though, in IJ form. So if I were you, I would do this and then write it like that at the end. Some other sort of visual aids there to sort of just help you understand vectors being represented. We talked about sort of negatives and so on. Stacking A's on the end of each other will create 2A. That line there says 2A minus B. So if you did an A, another A, and if you added on, as you can see here, if you added on minus B, you would get this vector here, which is called 2A minus B. So 11B, to have a go at some of these key ideas. We're going to keep going and just talk about magnitude and the unit vector. So magnitude, you need to be aware of the notation for this. We use these symbols, these sort of gates around the letters. It might be on the lowercase letters such as this, or on the uppercase with the direction itself. Magnitude is the length of a vector. So what we need to do here then is we see that it's 3 across, 4 up. Well, we need to do some Pythagoras. The long side should be 3 squared plus 4 squared square rooted, which is 5. The magnitude of this one here, notice we have a negative number, but the minus 1 will be squared. So we will always get a positive answer for a magnitude. This will always be positive. Okay, You won't normally get neat answers like these Pythagorean triples. It will often be an irrational number, a decimal, and so on. Okay. A magnitude of 0 would mean that the vector would be 0, 0. Even 2, 0 still has a length of 2. Yeah? If you go 2 to the right, 0 up and down, then the magnitude is still 2. And lastly, before we take a break, we're going to talk about unit vectors. So unit vectors, this does not come up quite as much as magnitude. Magnitude comes up an awful lot. Unit vectors are vectors that have a special magnitude. Their magnitude is 1. So imagine I had a vector of 3, 4. Okay, what's my magnitude? Well, my magnitude is 5. We know that it's 5 because we just saw that in the last slide. I would like a unit vector. And a unit vector, which is normally shown like this, has a magnitude of 1. So what would you need to do to my triangle such that that magnitude of 5 became a magnitude of 1? Well, you would need to shrink it down. You'd need to divide it. You'd have to scale it by a fifth or to divide by 5. So we're going to divide both the I and the j aspect, the x and the y, the top and the bottom. We're going to divide them both by 5. So the unit vector for A, shown by this hat symbol here, is 3/5 and 4/5. And if you're so inclined, if you perform Pythagoras on these, you will get an answer of 1. The shortcut, though, as it says over here, is take the vector and just divide it by the magnitude. So this one we did before. We also said the magnitude was 13. So I'll give you a moment to think about what the vector should become for the unit vector of A. Well, it's whatever it was from before divided by the magnitude. Whatever it was from before divided by the magnitude. What's this one here? So √2. And so we divide by √2, top and bottom. Okay. So you should now be able to have a go at questions from 11C.